Hi guys, I'm Amit from Networkers Technical Team, and today's topic is routing protocols. In this video, we will discuss about static routing with the next hop. So the first question is, what is routing protocols? So let's start. So routing protocol specifies how routers communicate with each other to distribute information that enable them to select routes between nodes on a computer network here. So routing protocols used by the routers, because as you know, there's a device routers. And why do we need routers? So if you need any communication between two different networks, so then we need routers. So how the routers will enable the communication between two different networks. So on that time, we have to configure routing protocols on top of the routers there. So routers will use the routing protocols to communicate between two different networks there. So routing protocols are the set of defined rules. Actually, what is routing protocol? It's a set of defined rules. It's already defined actually. So that is a set of defined rules used by routers, because routers only can communicate and will allow the traffic from one network to the another network there. That is a L3 routers to communicate between source and destinations. Okay, so routing protocols are the set of the defined rules used by the routers to communicate between source and destination. The network router protocols help you to specify way routers communicate with each other, and it allows the network to select routes between any two nodes on computer networks, guys. Okay, so routing protocols is a set of defined rules used by the routers to communicate between source and destination, and the source and destination will be present into different networks over there. Okay, so this is routing protocol used by the routers. So type of routing protocols. How many type of routing protocols are there? So routing protocols. So routing protocols are further divided into three parts. One is static routing, second is default routing, and third is dynamic routing. So then dynamic routing is further divided into two parts. One is IGP and second EGP. And IGP is further divided into three parts now: the distance vector, link state, and then hybrid. So distance vector is having the two protocols, the RIP and then IGRP. Link state having the two protocols again, OSPF and ISIS, and hybrid is having one protocol, so that is EIGRP. On another end, the dynamic, as you know, divided into EGP also. So EGP further contains path vector, and in the path vector, there is a one protocol only, that is BGP, Border Gateway Protocol. And then BGP further divided into two parts. One is IBGP and second is EBGP there. Interior Gateway Protocol is about IGP, and EBGP is Exterior Border Gateway Protocol. So IBGP, Interior Border Gateway, and E means Exterior Border Gateway Protocol. So this is the classifications of routing protocols. So in this video, we are going to be cover the static routing. So that's why I have highlighted this static routing protocols. So now static routing. So static routing is a form of routing that occurs when a router uses a manual configured routing entry, not the automatically. So it's all about manual configure. So if you will configure in the routers and in routing table, even in the routing table, if you will configure any routing entry manually, and if that entry will be used by the router, so that concept is known as static routing. The static routing AD value is AD defines administrative distance, and this value is 1. Now, the static routing can be configured by the three ways. The first is next hop, then second is exit interface, and this is next hop and exit interface. So in this video, this is the static routing part 1 video, and in this video we will discuss about next hop. So in the next 2 videos we will discuss about exit interface and then next hop and exit interface also. Okay, so static routing with next hop. So this is the network, guys, where these are the 3 routers which we are going to be used. I'll show you practical also today. So this is router 1, this is router 2, and this is router 3. So on router 1, there is a 10 network and there is a 20 network, and this is 10.1 IP, 10.2 IP, and 20.2, and then 20.3. So then we have to ping from network 10 dot from this IP, from this IP to, we have to ping to this one. So this, because this is all about present, this is all about communication within the same network. So now we have to communicate from one network to the another networks. So router will help us, and router will take the help of routing protocols. And which routing protocol we are going to be configured here? We are going to be configured here static routing with next hop here. Okay, so let's start. So now, so see, so this is router 1, this is router 2, and this is router 3 here. So from this router, we will ping with the router 3. Okay, so first of all, I'll mention here ping. Now 20.1.1.3 here. So if you will ping here, then this will be the packet format. This will be the packet format over here. So packet format will be, one second. So let me ping from here and ping with 20.1.1.3 here. So what will be the packet format? Packet format will be, looks like this. So source IP, destination IP, source MAC, destination MAC. What is the source IP? Will be 10.1. What is the destination IP? 20.3. What the source MAC? We'll check in its ARP cache. In ARP cache, do we have an entry? Yes, it's there. That is A. And then what about destination MAC? It will check in its ARP cache. Do we have any entry about the 10 dot, about the 20.1.1.3 MAC? Answer is no. So this is, guys, your ICMP. This is about echo request, because we are trying to ping. So as you know, if you will ping always use your ICMP protocol, and ICMP is always divided into 2 parts. If I'm talking about ICMP, so ICMP has 2 things: echo request, and second, it has echo reply concept. So now we are going to be generate echo request. But what's the problem here? The problem is an echo request. Okay, what is missing here? Right now, the destination MAC is missing, because this is the ARP cache of the router 1. Router 1 will check in its ARP cache. Do we have entry for the 20.1.3 MAC address? Answer is no. Okay, so because this is 20.3, so nothing is there. Okay, and then it will, even before that, router will check it in its routing table. Do we have any routes for that? So that answer is no. So even your router will not form this kind of packet also, because now there is a no routes there. Okay, so no routes, so then packet will be dropped. So why the packet is getting dropped here? What's the reason for that? The reason is because we don't have any routes, because once you will ping from here, so 20.1.1.3, so we'll check in its routing table. Do we have any routes? Answer is no. So packet will be dropped. Okay, so the, what is the error? Error is no routes. Okay, and we can say here route missing. This will be the error. Okay, so what's the solution? The solution is we need routing. What's the solution in this time here? The solution is all about routing protocols. Routing protocols over. So we need routing protocols. Okay, so let's configure it. So which routing protocol we are going to be used here? We are going to be used here static routing with next hop. That is what? Static routing with next hop on this router one. So in router one, I'll configure static route. So in the static route, what is the syntax? IP route, there's a syntax there. Then what is the destination network here? The destination network is 20 here. So then 20.1.1.0 with its subnet mask. And what is the next hop? In this direction, what is the next hop guys? 10.1.1.2. 10.1.1.2. So this is what next hop. So next hop is all about, you can say, this is the next hop, or you can say kind of your gateway. Okay, but this is the configuration. So once you will use this command here, so then your routing table will be updated. Okay, so this is the entry we have to do it over there. Okay, so okay, now, so the thing is, now you have to do the entry over there. So entry is all about, once you will configure the static route over here. So after that, there will be one entry on this router. So that is as a static route as a 20.1.1.0 slash 24 and via who will be the next hop? Your 10.1.1.2. So again, I'll ping from here. I'll ping with 20.1.1.3. So when you will ping with 20.1.1.3, then it will generate the packets again. Okay. Then that is source IP, destination IP, source MAC, destination MAC. It will contains a lot of information about ICMP, echo request and all, but this is the basic information. So this time router will generate the router. First of all, you will ping. Immediately router will check in its routing table. Do we have any routes for 20 network? Answer is yes. We have routes for that. And how to reach? You have to reach via 10.1.1.2. Okay, that's fine. 10.1.1.1.2. We will go out. The question is, when router will check in its routing table, when router will check in its routing table, do we have any routes or not? So that concept is known as route lookup. That concept is known as route lookup here. So this is the first route lookup. This is the first route lookup. And looking for what? Looking for network. Do we have reachability? Answer is yes, we have. After that, the question is, yes, you have reachability. The question is how? How you can reach there? The answer is it's via 10.1.1.2. Via 10.1.1.2. Okay, that's fine. But the question is, next question is again, do we have any routes, or do you know how to reach to the 10.1.1.2? Because if you are a router and if you are sending the packets from any network to, or from one network to another network, you need always exit interface. You need what? Always exit interface. But in this statement, can you see, is there any exit interface? Answer is no. There is a no exit interface. So the question is, you have routes to reach to the 20.1.1.0 slash 24 network, and that is via 10.1.1.2. And this is how that's happened actually, with the help of static routing with next hop. That's fine. The question is, how to reach to 10.1.1.2 and where is my exit interface? Because without exit interface, I cannot go out. So now again router will be confused. What the router will do? Router will do one more lookup here. So the first lookup, route lookup. Now second lookup for whom? The question is how to reach to the 10.1.1.2 and what is the next, or what is the exit interface? So then one more lookup over there. So this second lookup is known as recursive lookup here. Recursive route lookup. This is known as recursive route lookup. So in the recursive route lookup, second time it will looking for what 10.1.1.0 network, how to reach. So do we have any entry? Answer, let me check it. Do we have an entry? Yes, you have entry. And how to reach? And from where do you have to take the exit? I have to take the exit E00. E00, 0. Because see, if router is sending any kind of traffic, so first of all, it's need next hop. Okay. And that is in case if there is a no next hop, so that we can manage and router will manage it somehow. But exit interface must be there. Exit interface that must be there. Okay, in case if there is a no information about exit interface, then router will perform again one more lookup, and this second lookup is known as recursive route lookup here. So in the second lookup, the router one will get to know and now got to know okay, your next hop is 10.1.1.2. This is your next hop. This is your gateway. And from which exit interface you have to take the exit? You have to take the exit from E0/0 interface. That's fine. That's okay. So now what happened? Source IP. What is the source IP? 10.1. So that is 10.1. Destination 20.3. And what's the source MAC? Well, for the source MAC now, it will check in its ARP cache. Do we have any entry? Yes. A. And what's the destination MAC? Let me check in my ARP cache. Now destination MAC is not there. What is missing? Destination MAC is missing here. Okay, so let me just remove this one. Okay, I just static routing entry again, I'll make it. Okay, so now what happened here? So this is static entry and this is about 20.1.1.0/24 and it's how via 10.1.1.2. So now what is missing is destination MAC is missing. Okay, so for the destination MAC, so if we have to find out now, we have to find out what, or we are looking for what? We are looking for destination MAC address because that is missing. Okay, so if you have to find out destination MAC, so there is another protocol. Now another protocol will comes in the role, and the second and another protocol is about now ARP, address resolution protocol. So we are going to use ARP here. So ARP is further, it will be divided into two parts. One is as a ARP request and second is ARP reply. ARP request and ARP reply. Request is always broadcast. And this is always unicast. Always broadcast and that will be unicast. Okay, so what happened now? Router 1 at the place of ICMP echo request, it will generate now ARP request. So what it will generate? It will generate here ARP request here. This is the ARP request packet format. Now that is source IP, destination IP, source MAC, destination MAC. So what's the source IP? Will be 10.1. Second is what's the destination IP? Because what we are looking for the 20.3. 20.3 is what? The destination IP which my MAC address is missing. So now it means I'm looking for 20.3 MAC, but the concept is your source IP is 10.1 and destination is 20.3. That is what? 20.3. And ARP is, guys, always you can, or ARP can be happen always within the same network here, not from one network to another. So right now the source IP 10.1.1.1 Destination IP is 20.1.1.3. So this is not. So what happened now? At the place of destination IP 20.3, source IP. Source IP will be 10.1.1.1 and destination IP will be 10.1.1.2. Why 10.1.1.2? Because this is my next hop. You have configured next hop here. So now ARP request will be there for the gateway MAC address, or you can say for the next hop MAC address. So destination IP will be what? Destination IP will be here 10.2. What will be the source MAC? The source MAC will be, it's already there, that is A. And destination MAC, that is FF now. So this is all about your broadcast. Now the packet will reach to this side. So what this side will do? Okay, the packet reached to the another side here. What this side will do now? The outer two will update, will check it. Now, what is the destination IP 10.2? This is for me only. Okay, because I'm 10.2. What the source IP 10.1? What the source MAC A? Then it will update here 10.1.1.1 with A. And this is the dynamic entry, and this entry will be there for the next 4 hours. It will be there for the next 4 hours. It's updated here. After that, it will generate reply. So this is ARP reply now. So during the reply, source IP and destination IP, source MAC, destination MAC. So what's the source IP now? The source IP will be from here 10.2. What's the destination IP? Will be 10.1. What the source MAC? Source MAC is my on entry that is already present here. So that is B. And what's the destination MAC? Destination MAC will be your now AA here because it's already updated in my cache. And now packet will be unicast. Okay, so once the packet will reach to the router 1 will check it. What's the destination IP? 10.1. And what's the destination MAC? A. So this is for me. Then it will check it. What the source IP, from where is it coming? 10.2 and source MAC B here. Then it will update here 10.1.1.2. So now ARP is done and my ARP cache is updated on the both the ends. Okay. Now, so this is all about ARP here. Okay. So now ARP is done. Okay. And it's updated on the both the ends. Okay. So now again, router 1 will generate the packets here and it will check it. Now, you have to ping. So this is now C, source IP, destination IP, source MAC, destination MAC. What the source IP? 10.1. Destination IP in the ping you have already mentioned, 20.3. Source MAC. What's the source MAC there? Source MAC is A. And destination MAC is about now? About B here, because it's your gateway MAC address. Now packet will goes to the router 2, sorry. Router 2 will check it. Okay, after that it will add type and codes also. What are the type, what is the code, and then protocol. It's protocol 1, type 8, code 0, because for ICMP echo request, type is 8 and code is 0 there. And it's all ICMP protocol number 1. So the packet will reach to the router 2. Router 2 will check it. What's the destination IP? 20.3. Then it will check it 20.3. It's not for me, but on another interface, my 20 network is connected. So it means it's now means it's connected with me there. Then it will check it routing table. Do we have any routes? Yes, we have routes. And how to take the exit? You have to take the exit from E01. E01. Okay. So then router will take the routing decision with the help of its routing table, and then will try to forward the packet from here. But before that, now destination MAC will be added here. Means what the destination MAC? That is B, but B is just for this one. Okay. So what happened? This router will remove this MAC address. And then it will check its in routing in its ARP cache. Do I have any entry for the 20.1.1.3 MAC? Can you see, is there an entry? Answer is no. That is not there. That is not there. So what happened? So again, because what is missing now again, the same concept, destination MAC is missing. So what happened? Now router 2 will generate again ARP request. This is again ARP request here. So in the ARP request, this is source IP, destination IP. Source MAC, destination MAC. What's the source IP? 20.2. Looking for what? 20.3. Source MAC is C. Destination MAC, broadcast, because this is ARP request. This is the again second ARP request, but generated by R2 for the R3. It will, this entry will reach to the R3. R3 will check it destination IP. This is for me. Then it will check it. What's the source IP? That is 20.2 and source MAC C. Then it will update its ARP cache 20.1.1.2 with MAC address C. Okay. It's time to send reply back. So what this router will do, will generate the again ARP reply. So source IP, destination IP. Source MAC, destination MAC. So what's the source IP? Source IP will be 20.3. What's the destination IP? 20.2. What the source MAC? We'll check in its ARP cache. Do we have any entry with the 20.3? Source MAC D. It's the, what the destination MAC? It's C, and will be updated, and then we'll send the packet to this. Now this ARP reply will be received by R2. R2 will check it destination IP. It's 20.2. This is for me, and destination MAC is C here. This is all about unicast. Then it will check it what the source IP, from where is it coming? 20.3, and where is, okay, what's the source MAC? D here. So then it will update here. So 20, then it will update 20.1.1.3 with MAC address D and D. So this is again updated. Okay. So ARP is done. So let me just rub this one. So this time this ARP is between R1 and, sorry, R2 and R3. Okay. Now, so it's updated. Now, finally, in the destination MAC, what will be mentioned here? Destination MAC will be DD, because this is updated in my ARP cache. And finally, packet will reach to the customer. This router will check it what the destination IP 20.3, destination MAC D. This is unicast, and this is for me only. What is this? What is the type? What is the protocol? Protocol is 1. Means this is what? ICMP. And an ICMP type is 8, code is 0. So it means this is echo request here. Now it's time to send what? Echo reply. It's time to send what? Time to send the echo reply over here. Okay. So now it will send the echo reply. Okay. Now, during the echo reply, so this is echo reply packet here. Source IP, destination IP, source MAC, destination MAC, protocol, type and code. Okay, so then It will mention here the source IP, destination IP, source MAC, destination MAC, protocol, type, and code. So from here, what will be the source IP? 20.3. What will be the destination? Destination will be 10.1 because in the previous packet we have, because ICMP echo request, this router has received from where? 10.1. What's the source MAC? Source MAC is already there, D. What's the destination MAC? It will check it for the 10.1 in its routing table. It's not there. And obviously that is not possible because this is all about the same network. ARP cache is always about local network. So then what will be the destination MAC? It's all about. Now, sorry. Then it will check it. What's the source IP? 20.3. What's the destination IP? 10.3, 10.1. Then it will check in its routing table. Do you have any routes for the 10 network? Answer is no. What is not there? Reverse route is missing. Reverse route missing. Means you know how to reach from Bangalore to Delhi, but you don't know how to come back from Delhi to Bangalore. So this is one way you know, because previously we have entered this is manually. In the router one, we have updated in its routing table how to reach to the 20 network. But right now, router 3 is not aware about that, how to go back to the 10 network here. So then again, routing will be required. And which one? Then static routing. So then there will be command for the router 3, that is IP route. What's the destination network? Is 10.1.1.0 with slash 24. And what is the next stop? Next stop is into this direction, it will be 20.1.1. So after this entry, now router 3 will update its routing table. And entry will be 10.1.1.0 slash 24. And how to reach? Reach via 20 dot. How to reach? Go via 20.1.1.2. Updated. Okay, entry done, static routing updated. So again, next time the router will check it what the destination IP 10.1. Do we have any routes? Answer is yes, we do have. How to reach? 20.1.1.2. So the question is, when it's checking its routing table, this concept is known as, this is about first route lookup. Now the question is, you know how to reach 10.1.1.0 and how to reach via 20.1.1.2. That's fine. But the question is, from which interface you have to take the exit. So for that thing, need one more lookup here. So then router 3 will perform or will do one more lookup here. So this is second lookup. And this second lookup is known as what? Recursive route lookup. This is known as recursive route lookup. So in the recursive route lookup, the router 3 will get to know, okay, 20.2. So we have reachability for 20 network and how to take the exit E0/0. So it means we have reachability over here. Okay. So with the help of the second lookup, router will get to know, okay, yes, we have the reachability and how to go. First, next stop is 10.1.1.2 and how to reach to that next stop via your exit interface E00. Then it will check is in ARP cache. Do we have any entry for the source MAC? Source MAC is D. This is there. So it will be update. Destination MAC. So definitely 10.1 destination MAC is not possible. So then router 3 will look for its gateway. And for gateway, it will check in its routing table how to reach 10.1.1.0 and who's my gateway? 20.2. So then it will check the MAC address of 20.2 in our ARP cache. So do we have any entry for the ARP cache? Sorry, do we have any entry for 20.1.1.2 in my ARP cache? Answer is yes, it's already there. Because last time when the echo request came from R1 to R3, so that time ARP happened between. When echo request came from R1 to R3 last time, so that time between R2 and R3, ARP is already done and ARP is already happened. So this is the reason it's already updated. So now what's the destination MAC? What's the MAC of 20.2? It's C, will be updated. What's the protocol? 1. Type 0, code 0, because this is echo request. For echo request, type and code is 0. The packet will reach to the this router. Router will check it. What's the destination MAC? 10 network. Do we have any entry for that? Answer is yes, it's there. And from which exit, which interface you have to take the exit? E0, 0 here. So this is E0, 0. So it means we have reachability, and this is all about directly connected. So then it's fine because directly now you got to know about exit interface. So that's fine. So recursive route lookup is not required this time. But the destination MAC modification. So it will change destination MAC. It will check it. What's the destination IP? 10.1. Do we have any entry for this MAC address? Yes, it's already there. So check here. Do we have any entry? Yes, 10.1 is already there with MAC E here. Then it will mention AMAC. Okay, and finally, packet will goes to this one. So what happened now? So finally, this router will check it. Destination IP 10.1, destination MAC A, it's for me, and type is protocol is ICMP, and type is 00. So this is all about echo reply. Got it? So like this way, your static routing works with next hop. So in the next hop, what will be the concept? The concept is all about recursive route lookup here. So first of all, I'll just repeat the things here now. I'll summarize the things now. So when you will ping, so first of all, we'll generate echo request here. But in echo request, the source IP, it will check its now routes and all. If route is there, then it will generate source IP and destination IP. Source IP is about 10.1, destination 20.3, source MAC and destination MAC there. But for 20.3, if there is a no route, so then we have to configure what on R1. We have to configure static routing with next hop. Okay, that is with next hop here. So see, if I'm talking about the starting, okay, okay, so (10.1.1.2) with be here. So the first time when it will check in its routing table, do we have any now routes? Answer is no. So then we need static routing over here. So in the static routing, we have to mention 20.1.1.0/24. How to reach? Go via next hop, and that is 10.1.1.2 there. Okay. So router will perform the lookup in its routing table. Do we have any routes? Yes, it's via what? Via 10.1.2. So 10.1.2 fine, but the question is routers always, if you are doing, or if you are doing, or if router is trying to find the best path, or trying to find the path, or trying to find the destination, do you have the reachability or not? It's always need exit interface. So where is exit interface? This is not there. So let me do one more lookup. So the question is how to 20 is fine. The reachability is concept you have to go to 20, but the question is how to reach there. So that is 10.2. So the question is before reach to 20 networks, I have to reach where? To the 10 network there. So then it will perform one more lookup, and this second lookup is known as your recursive route lookup here. This is the main thing. This is the agenda for this video. Okay, recursive route lookup. So this is what we are doing. This is all about static routing with next hop, and in that what is happening? Your recursive route lookup. So It will generate echo request, then it will put it on hold, and then without MAC address, it will generate what ARP request there, and then about ARP reply will be, and then it will send echo reply. Okay, so in this, as per this topology, what we are using, so how many times ARP will be there? There will be 2 times of ARP. There will be 2 times. One is between R1 and R2, and second is between R2 and R3. First ARP is between R1 and R2. This is the first ARP, and second is R2 to R3. Okay, this is second ARP. Then recursive lookup. So there will be 2 lookup. So that is on R1, the first recursive route lookup here. And then on R3. So this is what? Second recursive route lookup over there. Got it? So this is all about static routing with next hop. So this is the lab case. Okay. So now, so this is router 1. Router 1. There is IP address is already there. Okay. Show IP interface brief. It's already there. 10.1.1.1 and show ARP. So 10.1.1.1 here. Is there any entry about the 10.10.2 MAC address? No, it's not there. Same, go to router 2 and check it. Show ARP. So this is, it's already updated. This is already updated. Okay. And then go to R3. So that is show ARP here. That is there. So means it's the ARP is already updated, because when I have assigned the IP addresses, I have pinged between these devices. So this is ARP is already updated. So this time, how many ARP will be there? Actually 1. But if you will perform it, if you will do this practical first time, so then don't ping. Okay. And then from here to here, then how many ARP will be there? There will be 2 ARP there. Okay. So now check here, go to router 1 and check its routing table. Do we have any routes for that? Show IP route. There is no route. Okay. Static. There is this command also. So is there any static routes? No, that is not there. So now what we have to do, we have to configure routes. So on router 1, and now try to ping with 20.1.1.3. That is not happening. The reason is because from router 1 to router 3, you cannot ping because routing table is not updated. Okay, so you can see you cannot ping. You cannot ping. Okay, so how to ping? So for that thing, we have to configure routes, routing table. Do show IP route static. You can see here there is no routing table. Okay, in the routing table, there is a no static route. So now let me configure it. IP route, where do we have to go? We have to go 20.1.1.0 network slash /24. But the next hop in this direction, you can see here in this direction, what will be the next hop? 10.1.1.2. So now let me configure here 10.1.1.2. So do show IP routes. So now you can see. So see here. Show IP route. In show IP route, so now let's consider I'm going to be ping here. So in the ping, my source IP will be 10.1.1.1 and destination IP will be 20.1.1.3. Then router will check in its routing table. Do we have any routes for that? Then it will check it. Do we have any routes? Yes, there is there. 20.1.1.3. How to reach? Reach via 10.1.1.2. 10.1.1.2 there. So 10.1.1.2 is there. This question is, where is exit interface? Where is exit interface? So that is missing. So for that thing again, and the question is, if this is your this source and this is your destination, and if you know there is a direct reachability is not there, first of all, overall goal is that we have to go to A to B. This is source, this is destination. But how to reach? First of all, you have to go to C and then B. So what's the concept? How to reach? A to C and then C to B. So this is the destination. But the question is now how to reach to the C there. Okay, so the same here. That's fine. 20 networks. It's via 10.1.1.2. But how to reach? And even second question is, where is exit interface? So two things are missing. One is exit interface is missing. And second question is how to reach to the 10 network. So then second lookup. So this is second lookup, and this lookup is known as recursive route lookup over there. So in this lookup, the router will check it. Okay, so is there any reachability to with the 10 networks? Yes, it's there, directly connected. And how to reach? Via E00. So now in the second lookup, we got the answer for this both the things there. The question is, the question was how to reach to the 10.1.1.0 network, or do we have any reachability or not? And the second is, where is exit interface? So both the things, these two things were missing over the one node there, okay, in the first lookup. So then in the second lookup there, we got to know, okay, yes, there is a reachability with 10 network, and that is directly connected. And how to reach? Reach via E0/0 here. So it means you have to take the exit to the E0/0 here. Got it? So let me go to the destination side and let me enable here debug IP packet. Go to R1 and now try to ping with 20.1.1.1.3 because we have reachability with that. But you can see here still we're not able to ping. What's the reason? The reason is your packet you are able to send, because from here the destination IP is 20.3 that we have already configured static routes for that. When the packet will be on this router, the router will check it in the routing table. Do we have any routes or not? Answer is yes, because that is directly connected on E01. And finally, packet will reach here. But during the reply, the source IP will be 20.3, but destination IP will be 10.1. Then in this router, you can check it here. Show IP route. Is there any static route? No. So what is missing? Your reverse route is missing. Okay, what is missing? Your reverse route is missing over here. So even you can see from router 3, the source IP 20.3 and destination IP is 10.1. And even in the debug messages, you can see here the source is 20.3, that is all about local, and destination is 10.1, that is all about from another network. So that is to the another network, and that is what's the reason? Unroutable. Unroutable. Destination unroutable means reverse route is missing. So what we have to do, then we have to generate the packets again. Okay, we have to configure here static route. So 10.1.1.0 and then /24. Then question is, who will be the next stop? So the C. In the reverse direction, who is the next stop? 20.2 here. So then mention here 20.1.1.2. Show IP route static. So this entry is there. Okay, and now go to R1 and now try to ping. You can see we are able to ping. because we have reachability over there. On the both the ends, we have reachability. So this concept is known as about what? This concept is all about your static routing. So this is static routing with next hop. And in the next hop, the concept is recursive route lookup. Okay, so the concept is it's all about static routing with next hop. Okay, and in this one, what's the concept we have learned? We have learned about recursive route lookup there. Okay, so in the next video, we'll discuss about static routing with the second. This is the first method. The second method is about exit interface. And then in the third one, then we'll discuss about next hop plus exit interface. Means this is a combination of first and then second method. So in this video, it's about we have discussed about recursive route lookup. Okay, and exit interface, there will be the concept about proxy ARP. So about the proxy ARP, we'll discuss in the next class. Exit interface and proxy ARP. So in this video, and we have discussed about recursive route lookup. Okay, means once more again, just one more thing, because there are some disadvantages about the recursive route lookup. What are those disadvantages? Static route, it's about 20.1.1.0/24 via 10.1.1.1.2. So the first lookup, let's consider you will ping with 20.1.1.3. So the first lookup is about, do we have any reachability or do we have any routes for the 20 network? Answer is yes, it is there. The question is how to reach via 10.1.1.2. Reach to the 10.1.1.2. That's fine. So the question is, do you have any reachability with the 10 network, or where is my exit interface? Or the second question is, because as a router, we need exit interface there. So what that is missing. So where is my exit interface? So let me do one more lookup. So this second lookup is known as recursive. So when this recursive route lookup is happening, guys, so obviously the router is doing the same process or same lookup again, which is already done once there. Okay, just recently this router is already done with the route lookup, but again we are doing, or again the router is doing the same lookup there. So this is recursive route lookup. So obviously this time the CPU utilization is almost double, because two times we are using it. Okay, obviously there will be impact on their performance there. So this is the kind of disadvantage you can say of the recursive route lookup. Okay, that is all about performance based there. Means more CPU utilization would be there. So we have to avoid this loop, this concept there. Okay, so in the routing protocols there, always we have to avoid recursive route lookup. Okay, then question is how to avoid recursive route lookup. Okay, so this is, guys, all about part 1 of static routing. So about this one, you will get the answer into part 3. So in the part 3, I'll let you know, okay, or we will discuss how to avoid recursive route lookup. So in the next video is about part 2, and in part 2, we'll discuss about static routing with next hop. And then in part 3, we will discuss how to avoid recursive route lookup concept. Okay. So guys, these are the commands on the router 1. IP route is the syntax there. Then 20 network, it's all about destination network. And then you have to mention the next hop there. So this is the command for next hop, static routing with next hop. Thank you guys for watching the videos.